So thank you very much for that kind introduction. I'm very happy to be here to present my paper elected as a top tumor paper of the year. The title is The Pluripotent Stem Cell Marker, Alkaline Phosphatase, is highly expressed in refractory glioblastoma with DNA hypomethylation. This may change the treatment strategy for glioblastoma. I divided my talk into three parts. First, the background of the study, the most prominent molecule affecting the survival of glioblastoma patients. This data was obtained antibody microarray. Second, the paper summary, the DNA methylation status, human methylation 450K. And finally, future direction based on the present result. This is a bar graph presenting each patient's survival time, chronologically arranged from the oldest cases in the left side and more recent case to the right side. As you can see, the survival time of glioblastoma patient is quite heterogeneous. So what makes the survival difference? This is the purpose of the study, and it can be a good therapeutic target for glioblastoma. We first compare the comprehensive protein expression between the tumors in the patient who survived more than 4 years. This is good prognosis group, and the patient died within 1 year. This is a poor prognosis group. The result was that the pluripotent stem cell marker, alkaline phosphatase, is highly expressed in the patient poor prognosis group. Actually, the patient with high levels of alkaline phosphatase survived significantly shorter time than the patient with low levels of alkaline phosphatase. So what makes the stem cell phenotype? All the differentiated cells had a higher level of DNA methylation, in contrast to the unmethylated DNA in stem cell phenotype. So we first compare the global DNA methylation status between the good and the poor prognosis group. There was no difference between the two groups in the factors known to affect the patient's survival. The result clearly showed that the poor prognosis group had significantly lower DNA methylation level, and methylation level of CpG site is calculated as Baylor value. That of 0 represents no methylation, and 1 does full methylation. Its mean value for good prognosis group was 0.5, and for poor prognosis group was 0.4. The difference was statistically significant. Furthermore, the poor prognosis group had a significantly lower DNA methylation level in the stem cell marker genes, including alkaline phosphatase or CD133. The methylation status of stem cell marker genes, especially at the CpG site in the promoter region, it looks quite heterogeneous and variable. So what makes the DNA hypomethylation? Hypoxia and TGF-beta are known as the main cause of epithelial mesenchymal transition, which induces highly invasive phenotype resembling the pluripotent stem cells. The glioblastoma with high expression of both hypoxia-inducible factor 1 alpha, HIF1 alpha, and TGF-beta had extremely poor outcome. In addition, we found that the high expression of TGF-beta concurrent with HIF1 alpha was significantly linked with DNA hypomethylation. So this is a hypothesized process of glioblastoma progression. Hypoxia combined with TGF-beta induces DNA hypomethylation, especially in the stem cell marker genes. So the cancellation of hypoxia can prevent the malignant progression of glioblastoma. So this is a conclusion of the study. Hypoxia-induced DNA hypomethylation is a promising therapeutic target for glioblastoma. Thank you for attention.